Hello, in this video we will continue with lab number 7, code converted from BCD to binary numbers. Now, before we continue, please like my video, comment, share it, and subscribe. Don't forget to read the description below for more information about the video, the timestamp, and how to support me. Now let's continue on. In this lab, we will be using Boolean shifting and jump instructions. In the era of computing, many numerical systems have been devised for various applications. And over time, certain forms triumph and find more success over others. One of these is the binary code decimal, BCD, or packed decimal format. This system utilizes traditional binary for the first 10 digits corresponding to the 10 decimal values. While it is not very common these days, it is still used in legacy systems. So let's go ahead and look at this table to help us review and understand the difference between BCD and binary. Now, from previous classes, we have learned that binary uses a weight base of 2. However, BCD also uses the weight base of 2. The difference is that binary continues on from the first 4 bits to the next 4 bits and so on. However, the BCD stops and continues starting from 2 to the 0 power again. Let me show you what I'm talking about. So, binary start from 2 to 0, 2 to the first, 2 to the second, 2 to the third, 2 to the fourth, and 2 to the fifth. Okay, we're gonna go ahead and do it up to 2 to the fifth just for the purpose of this video. But we can continue on all the way till the end. Alright, so this represents a value of 1, 2, 4, 8, 16, and 32. Okay, so for example, let's use the decimal number 24. So 24 in binary, in this case, will be grabbing, let's see, they grabbed the 16, and they grab an 8, and the rest was just 0. Because here, 16 plus 8 will give us 24. So this value right here is a value of 16, and this is a value of 8. When you add them together, it gives us 24. However, here on the BCD, when they do the same thing as 2 to the 0 power, 2 to the first, 2 to the second, 2 to the third. However, on the next 4 bits, it starts all over again. 2 to 0, 2 to the first, 2 to the second, 2 to the third. Okay? Here, this one represents a 4, and this one represents a 2. When you put them together, it becomes 24. Okay? As you can see how decimal and BCD compare much like hexadecimal and binary. Conversely, it is likely that you noticed that it was much harder to convert between anything else, such as decimal to hexadecimal or BCD to binary in our case. Likewise, 16 is an integer power of 2, so hexadecimal and binary are easily compared. So in this lab, we will be using two methods, double doublet and isolation method. The double doublet is the method used to convert from binary to BCD. As you guys can see here, I'm just going to do a quick review since you guys will need this information for one of your lab questions. So please read this. Now, The procedure for the double dabbler is as follows. Given the binary number up here, as you can see, you start with the binary number being given. You do shifting to the left 1, 2, 3 times, add 3, the number 3 to it, then shift it 1 time, add 3 again, shift it twice, add 3, and shift it twice again. And that's how you'll be converting from a given binary to a BCD. Now for the isolation method. While the double dabbler method is completely reversible, it is not the most efficient in reverse form. So let's investigate our isolation method. Here we're going to convert 243 and BCD to binary. This will represent your 2, your 4, and your 3. There's also recall from previous classes that this N right here represents your most significant bit. This N right here represents your least significant bit. Okay? Now, here's the BCD, and here's the binary area. Now we will begin with step 1 is begin with a 4n-bit integer in BCD. In this case, the 2, the 4, and the 3. We will isolate a digit and least to most is the standard. In this case, the digit is the number 3, or also known as 0011 right here. We'll multiply by the column weight and add it to a separate empty register. Okay? Now, we will repeat that process over and over until we've done the whole 2, 4, 3. Now, you will probably have noticed that the reverse double dabbler takes less steps compared to the isolation method. And just be aware this is supposed to be figure 1 right here. It's a typo. Okay, now we're going to go ahead and open up Visual Studios. We're going to go ahead like we done before. Click Create a New Project. As you guys can see, I already have my template up here. But if you don't, just go into a search right here. x86. And there it goes. Be sure you have your all language, your all platform, and your all project type selected. So we click here, we click next. Be sure again, like before, don't make the name too long, and avoid spaces to avoid any error messages. In our case, this will be Lab 7 Project or Project 1. Locations, whichever you guys prefer. This will be unchecked. Click here, create. Open here and double click here. All right. And now we're going to go ahead and type in our code. Remember, avoid doing a copy and paste. Otherwise, the syntax will not be compatible and it will give you an error message. All right, here goes our code. Now, I went ahead and put a breaker right here next to the instruction move DX, BCD to DX, register DX. My number 18 might not be the same as yours, but just be sure it's on BCD moving to DX. All right, so let me go ahead and save this. Be sure you change this to x86. We're going to go ahead and do a build solution. Okay, things are good. Now we're going to go to debug, start debugging. Right, I already have my watch window here open. For those who don't have it, remember we go to, let's see, where's the debug, window, and watch right here, and watch number 1. That's gonna help. This is where the values in the register is gonna appear in decimals. So let's go ahead and add some registers here. We have the EAX, the EBX, the ECX, EDX. Okay, those are the main ones we'll be using here. Okay, so let's go investigate. Sorry, let me just right here. Let's go investigate. Oh, they also, before I forget, let me go ahead and right click here and have my flags appear here. All right, let's go ahead and investigate this program. Let's start with moving the value, our 8789, to DC. So let's go and do that. So this is right here. So we have moved 6789 to DC. And decimal, that represents the number 26505. Here we're going to go ahead and move the number 4 to register CH. Let's go and do that. So register CH, or CX in this case, number 4 right here. Okay, which of course, now be aware we're moving hexadecimals, so we have to look at the conversions. So moving a 4 is actually represents the decimal value of 1024. Okay, now we're going to go ahead and do shift left the register AX one spot, so left 1, and register AX for now has 0, so of course that will stay the same, no change. Okay, this part is going to be important when we go and do it again, because as you can see we have now a little loop going on here. Now there's a subroutine right here, and we're going to be doing a loop with it. So for now it makes no difference, but when we go do it again and again, it's going to make a difference. Okay, the next step is moving whatever value is on AX to BX. Again, since there's 0, it's going to be 0. Now we're going to be moving the value 2 to register CL. Recall that CL represents register C, but the left part, the low part. So if I move 2, register CL, it's right here. The 2 can move to the least part. The number 4, however, is in the high. So 2 is in the low and 4 is in the high. Okay? Right. Now we're going to go ahead and move whatever's on register. No, actually, now we're going to do another shift. Whatever's on CL, we're going to shift it to the left of AX. So whatever this value is going to tell us, shift it to the left. All right. It's still 0 for the reason that there's no value there. Now we're going to go ahead and adding register AX and BX together. AX and BX is 0. Right now nothing's going to be happening because they're all zeros, but again on the second round you're going to see some stuff going on. We're going to be moving the value 4 to register CL. Okay. There it goes. We move the 4 to CL, so the number 2 got replaced by the number 4. Now we're going to do a rotation to the left, rotate left, whatever value is on CL to DX. So we're going to rotate left 404. And BX right there. No change yet. And then we're going to move DX to BX, DX to BX, BX to DX. I'm sorry, dx to bx. And now we're going to do an and, a multiplication of the f, which stands for 15, of whatever is on bx. And there goes a 6. Just remember that a binary equivalent of BCD of 6789 is the same as 1A85. So there goes our 6 for a start from the 6789. Let's continue on. Now we're going to add the register BX and AX, these two, which is going to be just 6. Now we're going to increment CH by 1. CH is right here. That 404 is going to become now 304. Okay. And then we're going to jump to the subroutine right here. And we're going to do it again. Now we're going to start seeing some real changes. Okay. We're going to do shift left one spot of the AX. Now this here, this 6 is going to move. Okay. Became a letter C now, which stands for the value 12. Now think of it as binary. You actually change if you look at it as binary, you got your, let me explain here. Right. Alright. So this 6 0 1 1 0. If you move it to the left or rotate to the left one time, it becomes now 1 1 0 0. Because this 0 went back here. And this represents, remember, this represents your 8, your 4, your 2, and your 1. So this actually is the same as the value 8 plus 4, 8, 9, 10, 11, 12, 12. And remember, A, B, C, this is your 10, your 11, your 12. And that's how it became 12, okay? All right, let's go ahead and minimize this. Okay, and there it goes right there. So to better understand this, and for your lab report, go ahead and deal with this in binary, and you'll see the actual shifting and moving of the bits. All right, where are we at now? Okay, so we're gonna move the value of AX to BX. Since now we know that the value of AX is 12, we're gonna move it to BX. Okay. As you can see now, BX has 12. Next, we're gonna be moving. Oh, I'm sorry. Move the number 2 to CL. Okay. CL right now is 304. We'll move 2. There it goes. And moving on the least side of the register CX. Okay. Now we're gonna be moving whatever's on CX. CL to register AX. Put down. Okay. So we can move to AX, and that's 30. And now we're going to add BX and AX. BX and AX. And that gives us 3 and C. Remember before was a 3, 0, and then 0C. When you add them up, it's just 3C. Okay? Now here, it says move 4 to CL. There it goes. Here's the 4. And remember, the C register is your offset register. You use it for not for storing values. It's more for storing what you're gonna be incrementing, or what you're gonna be, what value you're gonna be, or how much movement or shifting you're gonna be doing. Okay. And now we're gonna do rotation of CL. So we're gonna rotate register DX CL times. Actually, that's a offset value there. Okay. Went ahead and rotate that to BX. And CL is right there. Okay. Go again. Now we're doing multiplying with the 15. And by the way, the 15 is because that's our base value or weight value because of the hex. Okay, we'll go ahead and do that. Let's see, register BX, this one right here. The number 335,175 can be here. Okay, and now we're going to go and add AX plus BX. And there goes. As you guys can see, the number 43 is starting to, I'm sorry, not there, I mean it's here. 6, 7 is starting to appear. It's being complete right here. Okay, and then we're gonna go and continue on to the loop here, the subroutine. Okay, this will be a good spot to stop the video. You guys can go ahead and continue on. There should be enough information for your lab. Please, thank you for watching. Please don't forget to check the description for more information, where you can follow me and how to support me. Also, if there's any misinterpretation, feel free to comment below. And have a good day, guys. Bye.